Hey guys, so today we're dealing with quadratic functions. What is a quadratic function? It's an equation that's or a function, because that's what a function is. A function is like a type of equation where you've got like y by itself out the front, which is of the form this. So y equals ax squared plus bx plus c, where this a, b, and c, they're just random whole numbers. They don't have to be whole, but typically they are. So, for example, y equals 5x squared minus 2x plus 10. That's an example of a quadratic. You can see here that your a is a 5. That's the number with x squared. The b is a minus 2, and the c is a plus 10. Okay, so note, another way to think about quadratics is that the highest power of x must be a 2. So when I see this x squared, I think to myself, oh, that's a quadratic. So like, for example, y equals x squared. That's an example of a quadratic because of that squared there. So that's one way to think about it. Okay, next up, you need to know what a parabola is. So a parabola is the name of the curve when a quadratic function is graphed. So they look like happy or sad faces. So it's pretty much just the name of these curves. So if you get a quadratic function and you want to graph it, it should look something like a happy face or a sad face. And these curves are called parabolas. Now you get positive or negative parabolas. Pretty much the happy face is the positive version and the sad face is the negative version. And you can tell whether it's going to be happy or sad face based off the x squared. So if the x squared is positive, it's going to be a happy face. If the x squared is a negative, then it's going to be a sad face. So up here, I see that my x squared is positive because it's positive 5x squared. So therefore, I know that this quadratic has to be a happy face. Okay, so moving on, turning point. So the turning point of a parabola or of a quadratic is the tip of the parabola. So here I look at this happy face and I see that it turns here. This is my tip, like the end point. Well, not the end point, but the bottom of the parabola. So that's what I call the turning point. So there's my minimum value or my turning point. The minimum value is another word for it because that's as low as the parabola gets. And with a sad face, it's going to be a maximum point. So there's our maximum turning point, or the maximum value. And that applies to sad faces. So for sad faces, you have a max, and for happy faces, you have a minimum point. Okay, so moving on. The axis of symmetry is pretty much a vertical line. So like these lines here are axes of symmetry. It's a vertical line that pretty much halves our sad or happy faces, our parabolas. These axes of symmetry always have the equation x equals something. And you can look to see where it hits the x-axis to figure out what this question mark is. So for example here, there's my line of symmetry. It goes through at -3, so therefore that equation is x equals -3. That's my axis of symmetry. If you remember from a little while ago, vertical lines are always x equals something. Over here, my axis of symmetry is right here. That's -1. So x equals -1 is my axis of symmetry for that parabola. Okay, so moving on. Okay, so a few rules to remember. So when you're graphing these parabolas or these quadratic functions, a table of values is the way to go because it just gives you the points. So for this quadratic right here, it gives you the points that you need to plot. Here are my points. And so you can pretty much use these to graph them straight away. There are little shortcuts as you get better and better, but for now, just practice these tables of values. I know it's tedious, but it is what you need to be doing. So here for the first one, I've got 1, 2, 3, 4, 5 points. 1, 2, 3, 4, 5. There they all are. And same thing over here. So you can see here, just if you note, one of these kind of shortcuts that you can use is that this is our standard parabola. That's as simple as it gets. It's just a nice happy face that hits the origin at its turning point. And this is exactly the same, but it's got this -5 on the end. So pretty much everything has just gone down 5 points. That's kind of the idea. So it's pretty much as simple as that. Okay, so moving on. Note, for your graph, you should be able to determine the turning point and the axis of symmetry. So when you look at these graphs, you should be able to look at it and think, what is that turning point? So right here, I think to myself, well, that's 0, 0. And for this one right here, it's going to be 0, -5. You can also see them from your table of values up here as well. And the axis of symmetry can be quickly found as well by having a look at it. We think to ourselves, that would be our axis of symmetry. That is the line x equals 0, because it goes through at 0. And this one here, our axis of symmetry is exactly the same thing. X equals 0. It can change. It's not always going to be x equals 0 for our axis of symmetry. It's really important to remember that. Okay, good luck with the question.